Before we get to solving equations with inverse matrices, I want to review how to solve for x in a linear equation. In this problem, x is being multiplied by 4/5 and 1 is being added to x. In order to solve for x, we need to undo those two things. To undo plus 1, we're going to subtract 1 from both sides of the equation. Plus 1 minus 1 gives me 0, the additive identity. And when I add 4/5 x plus the identity, whenever I add anything to the identity, I get that anything. So I'm left with just 4/5 x. On the right side of the equation, 21 minus 1 is 20. Now at this point, most of you are used to just dividing both sides by 4/5. But I want you to think of it differently. In order to get rid of this 4/5, I'm going to want to multiply by the inverse of 4/5. So what is the inverse of 4/5? In multiplication, the inverse is the reciprocal. So the inverse of 4/5 is actually 5/4. So to get rid of 4/5 times x, I'm going to multiply both sides of my equation by the inverse. Now when I multiply by the inverse, I end up with 1. Any number times its inverse is the identity 1. And 1 times x is going to be x. So this 5/4 times 4/5 doesn't disappear. It really turns into 1, which turns into 1 times x, which turns into just x. And on the right side, I just need to do that math. 5/4 times 20 is 5/4 times 20 over 1. And I can take this 4 in my denominator and this 20 in my numerator and simplify. 4 goes into 4 1 time, and 4 goes into 20 5 times. 20 over 4 is 5 over 1. Now I can just take 5 times 5 and get 25 over 1 times 1. Let's apply that idea to problem number 2. If I want to solve for x, I need to undo the things that are happening to x. I'm going to have to undo being multiplied by this matrix and undo adding this matrix. Well, to get rid of this adding this matrix, I just need to subtract. So I'm going to subtract this matrix from both sides. When I subtract these two matrices, I end up with the identity matrix 0, 0, 0, 0. And whenever I add anything to the identity matrix 0, 0, 0, 0, I end up with that anything. In this case, this matrix times x. These two things don't undo each other. I get the identity, which then gives me what I have right here. On the right side of the equation, I need to do this math. Subtract corresponding entries. 9 minus negative 8 is 9 plus 8. Negative 3 minus negative 2 is negative 3 plus 2. 6 minus 6, 2 minus 1. Now to get rid of this matrix, normally I would just divide both sides by this matrix. But I don't have the division property, I don't have the operation division in the matrix world. Instead, I'm going to want to multiply by the inverse. Just like in problem number 1, instead of dividing by 4/5, I want to multiply by the inverse. So the first thing I need to do is find the inverse of this matrix. I'm going to do that off to the side right here. Now there's a formula that I can use to find this inverse, or I can use my calculator. Enter this matrix into your calculator. So I have this matrix entered in as matrix A. I'm going to quit back to the home screen. And then I want to find the inverse of matrix A. So I'm going to put matrix A in the home screen. And then if I look at this button right here, x to the negative first power, that is my inverse button. I'm going to find the inverse of the inverse of matrix A. When I hit enter, there's my inverse. So to get rid of this matrix, I'm going to multiply both sides of the equation by that inverse. Notice that the matrix that I'm multiplying by is going to be on the left side of the right side. And since this is on the left side of this part, I'm going to put this on the left side of my right side. Kind of like I had 5/4 on the left and 5/4 on the left. I'm going to do the same thing here. I have to have my inverse matrix on the left of my left side and on the left of my right side. Now these two are inverses of each other. So when I multiply two matrices that are inverses of each other, I'll get the identity matrix. And the identity matrix times x will just give me x. On the right side, I have a 2 by 2 matrix times a 2 by 2 matrix. So I'm going to multiply rows by columns. Rows times columns. Now I just need to do that math. Three plus -5 gives me -2. -4 plus 7 gives me 3. I can always check my answer by plugging this matrix into this equation and doing the order of operations and checking to make sure that I get this for an answer.